What if I don't give you the function? What if you have the given speedometer reading for a motorcycle? And in the top column, we have time. So that's time t. And in the bottom, not the column, row. The bottom row is speed, right? Or velocity, basically, v. So that makes sense. What if I told you we not always have the graph of the function? We might have just a list of data. And this is my data. So basically, we have a data. We don't have a graph, we don't have nothing else, just points. Can we still approximate stuff? Can we still estimate the distance traveled by the motorcycle using the velocities in the table? And we still, just with the same idea of left endpoints, right endpoints, we can use the beginning of each interval and the end of each interval. So we're going to be using left endpoints and the right endpoints. Yes, we can do it. And this is what we're talking about here. Step 1, we don't know the number of intervals, so we need to figure that out. And the mistake will be to think that this is the number of intervals 1, 2, 3, 4, 5, 6, 7. Nope. That's number of columns we're working with. So the idea here is to calculate how many intervals do we have. Interval is the change. From 0 to 5, that's one interval. From 5 to 10, 2, 3, 4, 5, 6. So delta t is, I will say it like this. N is 6. Either you calculate by hand like this, but what if you have 25? That was not very convenient to count by hand. Then you have this method. Find delta t. Delta t is the same change in this case in seconds we have from place to place. From 0 to 5 it's 5, from 5 to 10 it's 5, from 10 to 15 is 5. So it seems like change in seconds it's 5. Basically, speedometer cannot make faster records than every 5 seconds. It's like a camera making photos. How fast it can go, that's the time, that's the limit of the equipment we're working with. And in this case, every 5 seconds we make a record in a speedometer. If you have delta t, then by the formula we can actually calculate n. N is b or minus a over delta t. What is my b? B is the last endpoint, that's 30. 30. And then a is 0. Then we're dividing by 5 and we're creating the same 6 we had by calculating by hand. So either you calculate by hand if we don't give you too many, but if we give you 25 intervals, that's going to be annoying to calculate by hand, then you use the formula that number of intervals, that's number of intervals. Intervals in this case change in time. We have 6 intervals. Okay, let's do it very fast. That's actually not going to take a lot. For A, solution. For A, using left endpoints, I will call it L sub 6, will be 5 should be factored out because 5 is the same. Remember distance. Let me remind you. We had this in the previous video, but maybe you forgot. So we have distance can be found as what kind of product? Yes, velocity times the time, right? Velocity times the time, which is v times t. So basically s of t will be v of t times delta t. Time here is constant. The change in time is constant. V is always different. The record for v is different. Since time is constant and it's 5, I can just factor 5 out. Now I can add all the velocities from the table. Look at the second column. If I'm using left endpoints, then I start from the left. I will have v at 0 plus v at 5 plus v at 10 plus v at 15 plus v at 20 plus v at 25. And I'd skip the last one. Skip v at 30. Why? Because I'm supposed to have exactly 6 heights over here. So let's check. 1, 2, 3, 4, 5, 6. And that's how I know you have to skip the last one. Or because we're using left endpoints, then I know it's keeping the last one. Usually we need to plug 0 into the function of velocity, but we don't have the function. So what to do? That's even easier. Here velocities are all given. 5 factored out. V of 0 is 25 over here. V of 5 is 31 plus 35 plus 43 plus 47 plus 46. Done. The answer is the distance the motorcycle traveled with this recorded, not constant velocity. So first slow, then faster, 43, 47, 40, then start decreasing, 46, 41. The speed was different. But the record was taking every 5 seconds. Then he traveled 1,135 miles, he or she. Using right endpoints with the 6 intervals, 5 is still the same, but now I'm skipping V of 0. And I will have V of 5 plus V of 10 plus V of 15 plus V of 20 plus V of 25, and the extra at the end will be V of 30. So I skipped V of 0, you see, because we use only right endpoints. And I'm using the table, keep looking at table. I'm skipping 25, so I'll have 5 factored out. And then I start with 31 plus 35 plus 43 plus 47 plus 46 plus 41 at the end. And that gives me the approximation 1,215 miles. So that's the approximate distance this motorcycle traveled with the given data. Why it's approximate, not the exact? Because we are having the record every 5 seconds, and what happens between those 5 seconds is a mystery, right? Because the movement of the motorcycle is continuous. It's not actually jumping from 25 to 35. It was 25, 26, 27, 28, 29, right? Because we know that the speed cannot jump. The motorcycle is not jumping in space and time with rapid increase or decrease of the speed. That's why missing that information gives us overestimation or underestimation. To know the exact answer, like in the previous example, how did I get that exact answer? We're gonna teach you integration. Integration will give us the exact number. Then this approximation will be not needed anymore. Unless you're a computer scientist and engineer, you guys will be working with the approximation methods in your career, I'm pretty sure. Check new videos to know what's happening right after this, because it's getting more interesting. See you next time.